Alright, the next lesson is about solving quadratics using the quadratic formula. Just to wrap up what you've sort of learned in this unit so far, is that there are 4 ways to solve a quadratic. When you solve a quadratic, you are finding the roots. So the first way you learned was to graph and find the x-intercepts. I apologize for the typo here. When you are solving graphically, you are finding the x-intercepts. Sometimes you can get them from the table. The comment about flashy is an extra calculator lesson that's not required, and we did not do that. But you can get the x-intercepts from the table if it shows up. Okay, you can't solve every quadratic graphically, just some. Algebraically, you learned factoring. Okay, you can factor, set the equation equal to 0, factor, and solve. That only works for some quadratics. The lesson before this one dealt with completing the square. It works on all quadratics, but some numbers might become too difficult to work with. The variables must be on one side, the constant on the other, and the coefficient in front of the x squared must be a 1 before you start completing the square. And then today is about the quadratic formula. The quadratic formula works for all quadratics. The formula will show up on the formula sheet for the Regents exam, and you are allowed to use it if it says solve algebraically. Like I said, sometimes the Regents will make you do completing the square. I don't think they've ever made you do quadratic formula, but if it's a problem that can't be factored, quadratic formula is the way you're going to want to use it anyway. So this is really good to know. And like I said, this formula is on the formula sheet. So a reminder that the quadratic equation is y equals ax squared plus bx plus c. And the quadratic formula listed there is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So we're going to use the a, the b, the c, and plug them into that formula. Occasionally the Regents will tell you to round your answers to the nearest 10th or 100th. A lot of times they just say find the exact answer, in which case we leave the square root and simplify like we did in the previous lesson. This does give you the 2 answers because there's your plus minus. As we've been saying for the last couple lessons, it does give you the 2 answers even if you don't separate them. Alright, so let's jump in. Solve using the quadratic formula. First thing I like to do is write down what my a, b, and c are. So a, first of all, the equation does have to be set equal to 0 for you to do quadratic formula, unlike completing the square. So this equation is set equal to 0, so I am ready to start. A is touching the x squared, so that's 2. B touches the x, so that's negative 3. C is the constant, so that's negative 5. Remember, when you plug negative numbers into a formula, you need to hug them into parentheses. So here we go. X equals negative, and then the b. Well, the b is negative 3. I'll clean it up in a minute, don't worry. Plus or minus square root. Again, the b's negative, hug it, square it, so negative 3 in parentheses squared. Minus 4 times the a, which is 2, times the c, hug the negative 5, all over 2 times the a, which is 2. So all I did was substitute the values in, remembering, most importantly, to hug those negatives. Alright, so now it's just cleanup time. So in the front, we've got a negative 3. Well, double negative makes a positive. Plus or minus, and I'm going to write the square root. Now from here, what I want you to do is to just type the items under the radical. Do not type radical. So all I'm going to type is parenthesis, negative 3 and parentheses squared minus 4 times 2 times negative 5. And that gives me 49. So I'm going to write a 49 under my radical. and then 2 times 2 in the denominator makes 4. All right, so all I did was type in the contents under the radical all at once, and I got a 49. So the next thing I want to check is if that square root is going to disappear or not. So to see if it disappears, I'm going to hit square root of 49, and it comes out to be a nice 7. So if I type this into my calculator, hopefully you know it without typing it, but either way, the square root of 49 is 7. So now I am going to rewrite this as 3 plus or minus the 7 divided by 4. And since I don't have any radicals left now, all the numbers are pretty, I now need to separate it into my 2 different answers so I can make them nice looking numbers. So x could equal 3 plus 7 divided by 4, and x could equal 3 minus 7 divided by 4. Now remember, when you're dealing with fractions, do not type that all at once into your calculator. You will get the wrong answer. So figure out what the numerator is. 3 plus 7 is 10. Then do 10 divided by 4 in your calculator, and it's going to tell you 2.5. Okay, and then on this one, do the subtraction first. The numerator, 3 minus 7 is negative 4. Take the negative 4 and divide it by 4, and you also get a negative 1. So there are the 2 roots, the 2 places where your parabola would cross the x-axis. All right, now, just a helpful hint. If you get nice answers for the quadratic formula, and what I mean by nice is that you have no radicals in your answer, that means that problem could have been solved by factoring. Okay, that's just helpful information for a possible question that they could throw at you on the Regents exam. But when you don't have radicals left, you have nice rational answers. And if you have rational answers, that means you could have found them by factoring. Okay. All right, number 2. The instructions are to learn the quadratic formula. So this is the method we're going to use. And in order to do the quadratic formula, everything has to be on the same side. The equation has to be equal to 0. So I am going to subtract 6x from both sides. So that gives me 9x squared minus 6x minus 11 equals 0 when I put everybody in order. Next thing I want to do is write down my a, b, and c. A is in front of the x squared, so that's 9. B is in front of the x, which is negative 6. C is a constant by itself, which is negative 11. And now all I'm going to do is plug it into the formula, which I will write here so that you remember what it is. Okay, this is on your reference sheet. You do not have to memorize it. All right, here we go. X equals negative. My b is negative 6 in a hug. I'll clean that up in a minute. Plus or minus, hug the b, square it. So we get negative 6 squared minus 4 times the 9 times the negative 11. All over. See how I drew that bar all the way over to the equal sign? Okay, you might not think it's a big deal, but mathematically it would mean something shorter if you draw that line too short. Okay, it'll mean something totally different. So make sure that line goes all the way across. And 2 times the a, which is 9. All right, cleaning it up. A negative 6 is positive, plus or minus. I'm going to draw the radical, and now I'm going to type everything under the square root, not the square root sign. So parentheses, negative 6n parentheses squared minus 4 times 9 times negative 11, and I get 432. All over 2 times 9 is 18. All right, so the first thing I need to do is see if 432 has a square root. So I'm going to type in second x squared to get my square root bar, 432, hit enter, and I get a really long decimal. That tells me that the square root of 432 is not rational. So at this point, I need to simplify. So I'm going to move off to the side, and we're going to do our prime factorization hockey stick thing on that 432. Well, it's even, so I know 2 goes in it. 432 divided by 2 is 216, which is even. So do it again. That gives us 108. And 108 divided by 2 is 54. 54 divided by 2 is 27. 2 doesn't go into 27, but 3 does. So this is 3 times 9, and 3 times 3. That is one big hockey stick. Okay, I want groups of 2. So here's a pair of 2s, here's another pair of 2s, here's a pair of 3s. For every group of 2, 1 comes out. So I get a 2 from the first group, a 2 from the second group, a 3 from the third group. They all get multiplied. So 2 times 2 times 3 is 12. So this gives me 12, and I still have a 3 under the radical. So now I go back over to where I'm solving, and instead of the square root of 432, I'm going to write 12 square root of 3 all over 18. Now, if they say simplest form, you got to keep going. If they don't say simplest form, we actually could have stopped on the step before, but they do often say simplest form. Now, you actually have 3 terms here. You've got the 6, you've got the 12 root 3, and you've got the 8. For simplifying items with radicals, okay, numbers that are outside of radicals can simplify with each other, and numbers under radicals can simplify with each other. So that square root of 3 is not going to change at this point. But something that my previous math teacher taught me was that if you draw a heart around all the nice numbers, if you can find a number that divides into all 3 of them, then you can simplify this. So I'm looking at the 6, the 12, and the 8, and I'm going, you know what? They're all even. If you have even numbers, they can be divided by 2. So 6 divided by 2 is a 3. 12 divided by 2 is a 6, and 8 divided by 2 is a 4. If you can divide all 3 of them, do it. If you can't divide all 3 of them, then you leave it alone, and that's your answer. So now, since I could divide them all, my final answer is x equals 3 plus or minus 6 square root of 3 all over 4. Final answer, do not try to simplify the 6 and the 4. If you can't do it to all of them in the heart, then you don't do it at all. So we stop right there. Okay, those are very yucky, irrational roots. Since you have a square root left in the answer, that means there's no way you could have ever factored that problem. All right, number 3. Our first step is to get everything on the same side and set it equal to 0. Now, because I've been doing this for practically my whole life, I have always been trained to make sure your squared term stays positive. So I'm going to move these guys over to the left. So I'm going to subtract the 6a and add the 3. Subtract the 6a, add the 3. So these go away. And then I put everybody in order. So 3a squared minus 6a plus 3. And now that my equation is equal to 0 and in order, I can do my quadratic formula. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, so my a is the number touching the squared term, which is 3. My b is touching the middle term, which is negative 6. And yes, you've had 3 examples now where the b term is negative. That's not always the case. C is 3. All right, plug them in. X equals negative. My b is negative, so I hug it. Negative, negative 6 plus or minus square root. Hug your negative b, so negative 6 squared minus 4 times 3 times the c, which is also 3. All over, get the bar all the way across, 2 times 3. All right, cleanup time. Negative, negative 6 is positive 6, plus or minus. Now we need to type in negative 6 squared minus 4 times 3 times 3. So let's see. I think that gives us a 0. It does. All right, all over 6. Well, if I type square root of 0 into my calculator, it tells me 0. So my x equals 6 plus or minus 0 divided by 6. Well, separate your two answers because you don't have a radical left. So 6 plus 0 over 6 and 6 minus 0 over 6. Well, 6 plus 0 is 6. 6 divided by 6 means x equals 1. 6 minus 0 is 6. 6 divided by 6 is also 1. So I get a 1 twice. Well, how can a parabola cross twice in the same spot? Well, what this means graphically is since I got the same answer twice, then that means the roots of that parabola is actually only 1, and it happens to mean that's where the vertex hits the x-axis. So it is possible that the parabola has one root, and that's if your vertex touches the x-axis, and that's why you get the same answer twice. All right, so there were 3 problems for quadratic formula. You have 4 problems for homework. However, there is a situation I do want to make you aware of, even though it was not in the notes. So what if you have, let's put example 5 on here. What if you have 3x squared, minus 5 equals 0? I have no idea what the answers are going to turn out to be. I'm guessing they're not going to be pretty. But first of all, like I said, you have 3 ways to do this algebraically. One is to factor, second one's completing the square, and the third one is quadratic formula. Now, if you're good with factoring, that's probably where I would start because it's a faster problem that way. But the first thing I'm supposed to do when I factor is look for a GCF, and well, 3 and 5 don't have one. So because I don't have a GCF, I can't do anything with this problem. It's not difference of squares. So factoring's out. Completing the square would be my last choice, so I'm going to do quadratic formula with this one. But this one's different than the other ones we looked at because it is a quadratic, it has a square in the problem, but it doesn't have all 3 terms. So how do you handle things when it doesn't have all 3 terms? Well, you handle it just fine. The number touching the x squared is 3. What number is touching the x term? Well, the x term is not there, meaning you don't have an x term. Well, what number means you don't have anything? A 0. So you're going to use a b value of 0, and your c is the number that doesn't have a variable, your constant, which is -5. So if you're missing one of the terms, you're just going to use a 0 in place of it. So now if we fill it in, x equals negative, b is 0, plus or minus 0 squared, minus 4 times a, which is 3, times c, which is -5, all over 2 times 3. So x equals, a -0 is still just plain old 0, plus or minus. If you type that into your calculator, you're going to end up with a positive 60, all over 6. Well, square root of 60 comes out yucky, so we need to go and simplify it. I'm going to do that over here. Hockey stick, 2 and 30, 2 and 15, 3 and 5. Hockey stick, groups of 2. I only get one group, so I get a 2 that comes out. So ultimately I get, sorry, I'm going to have to move over here now, x equals 0 plus or minus, so here's my 2, and then 3 and 5 go back together to make 15, all over 6. Because there's a radical there, we want to draw the heart around my 3 nice pretty numbers. Is there a number that can divide into all 3? Well, they're all even, so I can divide them all by 2. 0 divided by 2 is still 0. 2 divided by 2 is 1. 6 divided by 2 is 3. So my final simplified answer is 0 plus or minus 1 square root of 15 all over, make sure that bar is all the way across, 3. And there's your 2 simplified answers. So if one of the terms is missing, you're just going to fill that in with a 0. Homework day 11 goes with this lesson. Good luck.